But we are going to look at the next lesson, which is about going to infinity with polynomial functions. And so what we did in the last lesson was we talked about rational functions and how you have a rational function, you have divided by 0, or you have a horizontal asymptote. Well, polynomial functions don't have that situation. Either as you increase your x value, your numbers go to infinity, or if you increase your x value, numbers go to a negative infinity. We want to show you how to do that. The main thing is that to go to infinity with polynomial functions, we have to use multiplying. So our simple example of x squared is infinity times infinity is still infinity, or negative infinity times negative infinity. Negative times negative is positive, and your infinity. So what we're saying is, as you approach positive infinity, your function also approaches positive infinity. As your x values approach negative infinity, your function approaches infinity. And that's because we're multiplying. What we're saying here in this little blurb, this little paragraph is that you can't subtract infinities and get an answer. So you can't go infinity minus infinity and think you have an answer, or 3 infinities minus infinity think you have an answer. It has to be set up so it's a product to figure out whether you're going to positive or negative infinity. So when you have our examples here, x to the 4th minus x, x cubed minus 2x, x to the 4th minus x to the 5th, those are like infinities minus infinities. So we can't do that. So we use our factoring skills, and again, we're pulling out the largest degree. So we pulled out x to the 4th, we pulled out x cubed, we pulled out x to the 5th. And by doing that, it kind of goes back to what we talked about earlier on in chapter 1 or chapter 2, and what we did in the last unit is now you've got this expression that you can evaluate as you go to infinity. So the multiplying part, as you go to infinity, or you can put negative infinity in this one, but infinity times infinity times infinity times infinity. That's the x to the 4th. Put infinity into the what's left in the brackets. 1 always stays 1. 1 over infinity to the cubed would be 1 minus 0. So you can do the algebra to figure out, as your x value gets bigger to the right, it becomes positive infinity. And if you put negative infinity in, you do the same thing. So similarly, when you have x cubed, you pull the x cubed out. X is infinity, infinity, infinity. The 1 stays as it is. 2 over infinity, 1 over infinity, right? So that's the algebra. Factor out, substitute, and then evaluate. So here, when you pulled out x to the 5th, now you have 1 over x minus 1. Infinity to the 5th is infinity. 0 minus 1 is minus 1. So as the x value gets larger here, that means your function is going to drop off to negative infinity. And then you can use that information about going to infinity to help you do some sketches. Again, this isn't really new to you. You did a lot of this in Math 30, right? You talked about your zeros and kind of areas of increase and decrease and that kind of stuff. So anyways, let's go. Infinity, when you put your infinity in, it's x minus 3, so it's infinity minus 3 is still infinity. That's squared. Infinity plus 2 is infinity, and 1 minus infinity is negative infinity. So as your function gets larger, as your x value gets bigger, you're dropping down to negative infinity. If you put negative infinity in, negative minus 3 is negative infinity. Negative infinity minus 2 is negative infinity. 1 minus negative infinity is positive infinity. Multiply this all out. So as your x values get smaller, you're also dropping down to negative infinity. So as you go to the right, you're dropping down into quadrant 4. As you go to the left, you're dropping down into quadrant 3. What are your intercepts? So again, back to some math 10, some algebra. Your y-intercept, x is 0, so you put 0 in for all the x's, blah, blah, blah. You get y equals 18. And how do you find your x-intercepts? Those are the zeros. So you have x minus 3 twice if you want. So x equals 3, all right? That's the bounce. X plus 2 is a factor. X equals negative 2, and 1 minus x is a factor. X equals 1. So we can plot 0 and 18. Do we say this was negative 2 and 0, 1 and 0, and 3 and 0? Those are the points. And as you go to the right, you're dropping to infinity. And as you go to the left, you're dropping to infinity. So no graphing calculator required, because you get to use your skills. So that's about doing limits at infinity. We're going to add a second lesson here, and it's about odd and even functions. And again, odd and even isn't really a huge thing. It's a nice to know in a sense. We've got a couple kinds of symmetry. If you have an even function, it's called symmetry to the y-axis. What we're saying is that the y value on the left side equals the y value on the right side. So for an example here, y equals x squared. If you put 2 in, 2 squared is 4. That'd be 2 and 4. If you put -2 in, -2 is 4, right? So your x's change signs, but your y values are equal to each other, and that's a even function, symmetry there. If you have an odd function, it's symmetry about the origin, rotating 180 degrees. What we're really looking at is the fact that if you got a point 2 and 8, if you make this point -2, so if you do the function of -2, then it becomes the negative of the y value, right? So f of x is 8, so negative of 8 is -8. So what we're looking at is if you change the signs, 2, 8 becomes -2, -8, and that would be a rotation about the origin, right? So that's called an odd function. So now if we start looking at 3 of our examples, x to the 6th, x cubed plus 1 over x, and 3x squared plus 2x minus 8. Odd and even is as simple as it sounds. This is even. 6 is an even number, so it's an even function. Left side equals right side. X cubed, and then x with the -1. There's no even exponents there. So this is actually an odd function again. So I actually plotted some points for us. -1, -2. If you change the sides, it becomes 1 and 2. -2, -8.5, to 8.5, right? So again, you got to switch both sides. So you're rotating around the origin. And then our last example, 3x squared plus 2x, degree 2, degree 1. That's an even number. That's an odd number. So it's not symmetrical to the origin, right? So it's not odd, and it's not even. It's not symmetry to the y-axis. So again, if you try to plot some points, -2 and 0, 2 and 0, they don't match up. So it's not symmetry to the y-axis. This was -1, and put -1 in here, blah, 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 -7. So -1, -7 is this point, 1 and 7 is this point. They don't match up either, so it's not odd. Okay, so that's odd and even. And what we'll do is we'll stop now, and we'll do another couple of videos, another video to kind of show the examples of putting all your graphing information together.